Welcome to Ready to Deploy, honest conversations on the real work that makes AI actually deliver. I'm Rashmeet Sangari, founder and CEO of Skypreem, and I've spent 20 years inside global operations at Johnson & Johnson, Amgen, Biogen, and I've seen firsthand what organizations need to do to get this right. The organizations that get AI right or deploy AI successfully are not the ones with the biggest budget. They are the ones with the right foundations. So that's what this show is about. Real conversations, the right sequencing that needs to be done to make AI actually deliver. So let's get into it. So I'm very pleased to welcome our first guest today on the show, Arlen Nipper, who spent 40 years building the infrastructures that others deploy on top of. In 1999, Arlen Nipper co-invented MQTT, the messaging protocol that now powers billions of industrial devices worldwide. He's seen more failed deployments than probably anybody alive in this industry or working currently. So I'm really looking forward to speaking to him. Arlen, welcome to Ready to Deploy, and can't wait to have a good conversation with you.
Well, thank you, Rashmeet. I appreciate that. So again, my name's Arlen Nipper, and I am the president and CTO of SiriusLink Solutions. I've been doing industrial automation, communications, however you want to lump that in, for 48 years now. So I've been the CTO of several embedded computer companies. That was kind of my start as a computer engineer. And I've slowly migrated from embedded hardware to more software-centric solutions.
Amazing. Okay. Thank you for that introduction. Let's get into some of the questions for the podcast. So my first question, Arlen, that I would like to cover is, I would like to ask you that before MQTT existed, what was actually broken about how industrial systems share data? And what problem were you actually trying to solve?
Well, when I got out of college, my first job was with Coke Oil. The Koch brothers at that time were heavy into the oil and gas industry. So my first job for 8 years was as a SCADA engineer. Now, you have to realize that, 1980 timeframe, the Modicon PLC and Modbus itself was invented in 1978. So literally, we were just getting in to, I would say, talking to equipment. Everything was using 32, and there may be some old engineers on this call that still have an old laptop that has an RS-232 port on it. But that was how we worked. So our infrastructure, if you will, both in a factory or on, like in this case, a pipeline, our infrastructure was serial communications. We had to poll devices and they would respond with their registers back. And then we would put that information on the screen and it would fall on the floor. And then we would poll those devices again and it would come on the screen and it would fall on the floor. So,
Amazing.
I dealt with from, 1980 until 1999 when I started working with Andy Stanford Clark from IBM. I dealt with literally hundreds of proprietary equipment protocols. Everybody that invented something is, I've got this notion is I was an embedded computer engineer. And when you look at what we do when we replace a mechanical process. So I'll give you an example, flow computer. A flow computer basically measured the differential pressure across a known orifice size, and it had a Bourdon tube that would draw a line on a round chart. And once a week, you would go and you would pull off that round chart and you would integrate the area under the curve. And that was your volume of product that flowed through that pipeline over that orifice. So what happened in the early 1980s is companies started taking embedded computers and they would measure that differential pressure. They would compute that area, they would compute the volume. And my notion is that the company would invent this device and then sales would go, oh, Joe, the embedded engineer, Joe, the company loves our product, but they want to talk to it.
Right.
And so the embedded engineer would go, well, I invented this, so therefore I must invent a flow computer protocol to talk to it. And if you look at we are That was, 40 years ago, 48 years ago.
Mm.
And we're still in that mindset of that's where all of our legacy infrastructure came from. It came from serial devices talking poll response protocols. Okay, we got new things like TCP/IP and Ethernet, but if you look at that, what's still the most popular protocol in the world is Modbus, and it's literally encapsulated inside of TCP/IP, but it hasn't changed. It's
Right.
still a poll response protocol.
Right.
So I think from my standpoint, the problems that existed up until that point, it was all incremental. We didn't know
Hmm.
then what we know today. It was
Hmm.
all incremental. So my career, if you will, before 1999 was just building protocol converters for mainly the oil and gas market at that point in time
Right.
that would convert a legacy protocol to Modbus. And then we would get that into their SCADA host system. And then we would have another protocol and another one and another one. So
Right.
that was what existed before Andy and I worked together to invent MQTT.
Hmm. Interesting. Okay. Yeah. No. Thank you for sharing that. That's very interesting to hear how things have now changed. Right. So my next question is more around the fact that MQTT was invented in 1999, right? But really didn't become the dominant industrial standard for over a decade. What was missing in those early years, and what had to become true before organizations really started deploying it successfully at scale?
Okay, well, if we go back, basically the genesis of MQTT, the actual event that happened that caused us to actually look at inventing it, it might surprise you. It was basically the deregulation of AT&T. So in the late 1980s, T would provide private four-wire circuits to anywhere in the United States.
Right.
And they were very good. They had
Mm.
a central test center that you could call if you had any communications problems. So really life was great. We would put these serial devices out in the field or in the factory. But after AT&T got deregulated in the late 1980s, slowly all of that infrastructure started to go away. And the VSAT vendors, Gilat, GE SpaceNet, Scientific Atlanta, AT&T Tridem, they all
Right.
kind of came in and started providing VSAT, a very small aperture terminal satellite systems to go out into the field.
Interesting.
But the problem was, again, right? I'm an embedded engineer, therefore I must invent the protocol. All of these satellite vendors had proprietary backhaul protocols to get that data from. So I've got a remote location in West Texas. I've sent data over the satellite. It's got to come down to the ground earth station. It's got to come back to my SCADA host system. And
Right.
that was all proprietary. The event that happened was in 1999, actually 1998. Phillips 66 in Bartlesville, Oklahoma, got a brand new AT&T Trident VSAT system, and it was using a transport that your audience will be surprised that really wasn't prevalent. It was called
Mm.
TCP/IP. TCP/IP, we were still polling over the satellite system. The
Interesting.
problem was it took Phillips 66 15 minutes to poll all 500 of their booster stations. So if you can imagine from an operations standpoint, if you're an operator,
Yeah.
you're going to look at one station
Yeah.
and now it's going to be 15 minutes before you look at it again.
Right.
Pressures could have changed, tanks could be overflowing. You don't know.
Yeah.
So Steve Koenig was the SCADA supervisor at Phillips 66, and he had a good friend that was the IT manager. And he said, "Hey, Steve, we're using this new message-oriented middleware from IBM. It's called
Mm.
MQ series, and today we know that as an enterprise service bus."
Right.
And he said, "It's very interesting. I can decouple my IT applications by publishing information to a data broker,
Mm.
and then I can have other applications subscribe to that. And it's very fast, it's event driven, and it
Mm.
decouples all my IT applications."
Mm.
So Steve started thinking about that, and he said, "Hey, Arlen, can we publish information from all of our booster stations. Instead of polling, taking 15 minutes, can we move that polling to the edge and then just publish that information?
Right.
So Andy Stanford Clark was with IBM at the time, and he had 20 years of experience with IT. I'd
Mm,
been doing OT for 25 years,
mm,
and we got together and we took the big IBM MQ, which was a huge overhead, and we kind of set a goal because every byte on the wire was $50,000 a year to Philips. In other words, every
wow.
time we got rid of another byte of overhead, that was $50,000 a year to Philips.
It's huge.
So that's why MQTT is lean, it's
Mm,
fast, it's
mm,
efficient.
mm,
And when we got done deploying MQTT for Philips,
mm.
we went from 15 minutes to 10 seconds. That's how much of a step change it was in
Amazing.
publishing information from the remote sites instead of having to poll for it. Now, the problem is that Andy and I did manage to keep it open because I wasn't an IBM employee. So we were able to keep it open instead of IBM patenting it.
Right.
But the only place that you could get an MQTT broker that was commercially supported was from IBM, and that
Mm,
was a
mm,
200, $300,000 cost. So
mm,
you asked the questions, why did it kind of just lay quiescent within IBM?
mm,
Well, it's when people started that there was MQTT broker project by Roger Light called Mosquito, and
mm,
probably everybody that's played with Node-RED and MQTT probably played with the Mosquito broker.
mm.
And then kind of I don't know, I guess what really broke the ice was that Facebook Messenger, the first version of Facebook Messenger for your phone was very, very slow.
Right.
It ate your battery. And so the Facebook team were challenged with coming up with a better way to do Facebook Messenger for mobile devices.
Mm-hmm.
And they found the specification that Andy and I had published, on Eclipse Foundation, and they basically used that to re-implement Facebook Messenger. And they did a really nice one-page blog post that basically said all of the things that MQTT, it's stateful, it's efficient, the battery usage was minimal. And then people started looking at that. I think things like the Raspberry Pi started coming out. And
Right.
then this technology became available to, I would say, college students, to the engineering community at large. And then, as you stated, here in the last 10 years, it's really exploded.
Yeah, absolutely. Absolutely. And I do want to highlight to our audience as well the beauty of collaboration, right? Because I think this came about as you had experience in OT, you worked with someone who had high experience in IT, right? So that's the key. That's really important when you're trying to deploy any technology or you're trying to do something new. So kudos for
And
you.
it really was when you look at it. Andy and I weren't trying, we didn't start. There was no cloud computing. There was no
Mm,
notion of the Internet of Things. We
mm,
were trying to solve a problem. And I think the genesis of MQTT came out of just simply sitting back and going, okay, we've got a new technology, TCP/IP, that will let us talk anytime we want. And I think, we've talked, prior to this
mhm,
podcast.
mhm.
And I think the reticence of SCADA engineers embracing things like MQTT was it was so foreign to just being able to publish data when it changes instead of having to poll for it, that it took a long time for people to wrap their minds around how an MQTT infrastructure and technologies that we'll talk about here in a bit, like universal namespace, can work
Right.
in providing you a foundation for your AI.
Right, right. Absolutely, absolutely. Now, let me switch the conversation a little bit, Arlen, and ask you what happens when organizations don't do the foundational work and start to deploy technology. So let's talk about the dark side, right? What happens when, in your experience, what have you seen?
Well, going back to what I was talking about, kind of in my world, the root of all evil is protocols. Because
Mm,
if you think about it, protocols make you tightly couple an instrument to an application. The application knows the protocol. It's going to poll that device. That device is going to respond. And now, where does your valuable OT data live? It lives in this machine that's doing the polling.
Right.
But you may want that data elsewhere. And so now you write a little application that gets it out of there, and now you've lost your single source of truth.
Right.
And so in my mind, the power of MQTT is basically 3 steps. Number 1 is it lets you decouple.
Hmm.
Now devices can be decoupled from applications. If you're
Hmm.
publishing information into just an MQTT broker all the way back to 1999,
Hmm.
that IBM was promoting messaging is it lets you decouple your IT applications.
Right.
So think of MQTT infrastructure as the enterprise service bus for your factory, if you will. So
Yeah.
number 1, it lets you decouple. It lets you provide a single source of truth,
Mm-hmm.
and it lets you demonstrate a superior OT system first and foremost. And
Right.
I think the problem, Rushmeet, is that we're having people jump in with
Hmm.
cloud, with
Hmm.
AI.
Hmm.
They don't have the foundational
Hmm.
infrastructure the way they need it. They don't have that single source of truth. And so that project, I guarantee you, is going to fail.
Right. Yeah. 100%. 100%. And you said something that that really stuck to me, right? That people who are looking for data they don't want to be attached to that device. They want to be able to look at that information, sitting anywhere, sitting at their home, right? And that's really key. Supply chain visibility is really key for any company,
Mhm.
and I think that's the beauty of what you have done, right? To make sure that you are able to decouple the two. So yeah, let's continue to dive into it. My next question is around data quality, right? Because I understand, having lived in this world as well, I understand that garbage in is garbage out. So high data quality is really, really important. In your experience, bad data quality can be a silent killer for projects. So what in your experience has, bad data quality done to an organization? And can you share an example when you've been able to turn it around or have experienced that?
Well, let's go back to that very important notion of a single source of truth.
Right.
So this Opto 22 PLC over my right shoulder here that's flashing red, green, and blue, that is a device that can connect to analog I/O, can connect to digital I/O, and it can publish MQTT messages directly. So now I know that if I've subscribed that information, I've got that single source of truth. I've got that data quality. But let's
Mm,
step back. Let's
mm,
say I've got an instrument in the factory and it's Modbus or it's Allen Bradley or it's some other proprietary protocol, and
mhm,
I've got to go get a register from my equipment, let's say
mm.
a Modbus register, and it's got a value of 22. 22 what?
Yeah.
Is that 22 degrees? Is it scaled? Is that a 0 to 1024 value that I need to scale 0 to 100? Does
Yeah.
it represent PSI? Does it represent degrees C? So we have, again, with these protocols, we have that machine that a human being has got to go in and edit that point. And if he fat fingers that, if he makes an error in editing, that no longer becomes a single source of truth. And in many, many factories, that silo, that layer, especially if we're in a Purdue model where we're going from layer 0 to layer 1, layer 2, layer 3, it may go through so many transitions that nobody remembers where it came from or
Right.
what it was. And to me, that is the data quality problem. The more equipment that we can get, or the more we can do edge of network devices like the Opto 22 or Phoenix Contact or Moxa or IO Logic, there's just a whole plethora of devices that can be proper edge devices. And we get that single source of truth moved as far to the edge, if not in the equipment, as we can.
Right.
And now we've solved that data quality problem. But as long as we're polling, as long as we're editing registers, we will never have the data quality that we need to go in. And it's really the serendipitous nature of data.
Hmm.
If one of our very first customers 8 or 9 years ago, was Carl Voss, and he was the IoT officer, if you will, for TE Connectivity. And TE Connectivity manufactures millions of electrical connectors. He said, Arlen, what I want to do is I want to be able to walk into my factory with proper permission, plug my laptop in, and I want to be able to learn my entire factory in 10 seconds.
That's right.
And that's what this technology that we're talking about with things like the spark plug specification, with MQTT and proper automation, now you can get to that point. And it's only at that point do you look at going to, okay, now I'm ready to look at AI.
Right.
Because if you can't do that up until that point, you're going to fail.
100%. Yeah, I couldn't agree with you more. I myself have been involved in many initiatives where where our goal was to provide visibility to the end-to-end process, right, on how a product would move. So this is really critical. Now, my next question, I think, would be very interesting to our audience, especially people who are supply chain officers or digital officers or leading digital transformation. And what I would like to know is if someone from biotech industry, the pharma, or any industrial company came to you and said, Arlen, I need to deploy artificial intelligence. I have this mandate. I don't know where to start. What would be your recommendation?
Well, you and I both were at the Prove It conference in Dallas. And the Prove It conference is largely based on this notion of a unified namespace. And the kind of the mantra there is connect, collect, store, analyze. If we're not connecting and collecting and storing, then if you've got that mandate, so if management came to me tomorrow, I was managing a typical factory, pharma or whatever, the first thing I would do is go do due diligence on all my equipment, all my devices, all of the process variables that I think that I know where those are coming from.
Right.
And then the other thing that I would do is do a survey of how much data you're leaving stranded in your facility. We did a study, I don't know, probably 5 or 6 years ago, where probably 80 to 90% of valuable sensor information is being left stranded in the field. Because if you walk in, okay, so again, here's the executive that was given a mandate, and that executive goes to the factory and he goes, where's my OT data? And they go, it's all right here, Joe. It's in the SCADA system. It's in this factory automation system. It's right here. And I guarantee you, all of that data is operational data only. It's not supply chain information. It's not CRM information. It's not ERP information. It's only what the operators wanted to see come on the screen. They reacted. It fell on the floor. More data came on the screen. They reacted. It fell on the floor.
Right.
So right there, you don't even have a starting point.
Yeah.
You're not even at a point that you can get started with your AI initiative. So you have to step back, reevaluate, and say, okay, let me go all the way to the source of all of my information that I'm pulling in and see if I can't take step one, which is connect, collect, and store. And what we saw at the Prove It conference is there were 50 different vendors that were all connected into 3 types of factories using MQTT and the notion of the unified namespace. And we can go into the unified namespace in more detail here shortly.
Sure. Yeah, no, I fully agree. You know, the need to do the foundational work, and I love that notion of connect, connect, right? And I think for us as well, right, at Skypreem, we help companies essentially look at that data, look at how do you connect that data, how do you structure it, right? How do you streamline the processes? So I couldn't agree with you more. Now, let me ask you, another question, which is a very important one, especially when it comes to talent development, employee motivation, right? Because in my experience, any initiative, no matter how good it is technically, right, can fail if the right people are not supporting it. So what, in your experience, has happened when things go right, when you've deployed AI? What changes for the people? And then a connected question is, how do you motivate people? How do you make sure that they get on the journey with you?
Well, I think We can talk about technology all day long, but it really is about people.
Right.
And the most successful projects that I've seen go right is that they've got, and Henry and Sherry and people on the factory floor, they've got them bought in all the way through executive management. We know what our goal is. We know what we want to do. The worst thing is you're walking through a factory and people are whispering, going, they're going to bring in AI.
Right.
That is not a very conducive environment for that to be productive.
For sure.
And we're all hearing about AI and, that it's replacing jobs. It can do this, that, and the other. But I guarantee it can't run a factory. It
Yeah.
can make people better
Right.
to run a factory, but
Right.
it's never going to run a factory. There's always tribal knowledge. There's that subject matter expertise that it takes no matter what.
Yeah.
So I think our job is to go in and before you connect, collect, store, analyze, you get an environment set up and talk to the operators, talk to the people running the facility and say, what would you like to see? I already know this process better than anybody. What information are we leaving stranded at each of our stations, as through the process of manufacturing something?
Yeah.
That's the hard work. We've done many, many complete digital transformations, taking a company from 100% legacy pull response to 100% event driven MQTT UNS digital transformation.
Well,
But the technology was only 20% of the effort.
that's right. That's right. 100%. Yeah, I fully agree. I think that we need to work very closely with people as we deploy any initiative. And the people on the floor, right? They are living the process day in and day out. The
Well, it
more,
won't. I guarantee you that if the operators don't, if it's, they can make it not work. I
that's
mean,
right.
you've got to have people bought in. And I
That's right.
think a lot of people just think, oh, we're going to come in, we're going to dictate this transition.
Right.
And I don't think it's a matter of dictating. I think if you talk to people and you get together, and, you don't have to everybody get on a Zoom call every day, but have that discussion and have a living document that tells you what you're going to be accomplishing once you get this digital transformation done.
Yeah, 100%. 100%. I think organizational readiness all the way from top to bottom is huge. So, yeah, well said. Now, my next question is, what is the single biggest mistake that you see leaders doing when they are trying to deploy automation or artificial intelligence or get on in this journey?
Other than all the mistakes we've already talked about, I mean, I think there's, again, well, I do know one of the biggest mistakes is that we have done successful digital transformation at the OT level. Remember what I said? Decouple,
Mm-hmm.
provide a single source of truth, be
Mm-hmm.
able to demonstrate a superior OT solution. We've
Mm-hmm.
done that time and time and time again.
Mm-hmm.
But then they'll say, okay, now we want to take it to Snowflake or Databricks or Azure Cloud, or, I want to go to AWS SiteWise. And okay, great. What do you want to do? We don't know.
Mm-hmm.
And so I have so many people that have data lakes that have turned into data swamps that nobody's using because they didn't even know what they wanted to accomplish. So
Mm-hmm.
don't be, again, we can push data into Snowflake, and that's a really elegant solution. We can populate the UNS into the Snowflake Data Cloud platform, and then you can run Cortex on top of that. But here
Mm-hmm.
I've got 14 million tags going into Snowflake. Well, I'm creating a very large bill, but am I creating value?
Right.
And I would back up, say, we've got the ability. Let's take a very small amount of data. Let's publish that up. Let's get that into our AI infrastructure. And let's just see what we can accomplish. Let's get one small win. And then it's the land and expand principle, right? You land, you do something correct, and then you expand.
Yeah.
And I've seen so many companies, they've got this gargantuan, just huge, vision of what they're going to do. And it just turns into, like I said, a data swamp.
Yeah. Yeah. Yeah, I mean, you said few important things there, very important things, right? One, I would say knowing the goal that you want to achieve. the ROI associated with it, right? I have seen so many initiatives in my own experience where companies and organizations have invested money, right? And you invest money and you don't get much out of it, right? Because the goal hasn't been defined appropriately, it wasn't vetted properly, right? And even now, when I coach my clients, I make sure that we understand the ROI before we get into it. So I think that's really important.
Yeah, and in having that, there will be this realization once you do your digital transformation and you've got some of your non-operational data so that people can actually see what's going on. That right there is kind of an epiphany moment when they
Yeah.
go, "Oh my gosh, I didn't know all of this was going on in our process." Okay. So now you've got that, you've created a foundation where they could start looking at that and go, okay, let's take this and let's optimize this process. Let's
Right.
take that. Maybe we can do some AI. Maybe it's only machine learning. Maybe it's predictive maintenance. You don't have to eat the elephant
Correct.
in your digital transformation journey. But if you
Correct.
can get up to the level where you've got data flowing, you've got that single source of truth, you've got a known unified namespace, i.e., everything is defined and is
Mm,
publishing in to
mm,
hierarchies that
mm.
then I think you're ready to make that move. And until you get to that point, if you can't point to your UNS and say, yes, definitely, I know that single source of truth, quality data, you're going to fail.
Yeah. Yeah, fully agree. Fully agree. And I also love your point around doing pilots, right? The need to show wins early. I think that's really important, especially when you go in a big organization, because fortunately or unfortunately, people don't have the patience to wait for that big thing to deliver, right? So it's really important to go in, show some credible wins, and then progress from there.
Yes, and I think done properly, again, that's why I love the Prove It conference. That's why I like the notion of the UNS
Right.
is that you can connect, collect, store, analyze, and you can do that in a POC and you can scale it.
Mm,
Okay, very easily. If you take a POC where you haven't done that properly and you go, oh, great, the POC is working. Now let's scale across the entire facility. That would be guaranteed failure.
right. Right. Exactly. Yeah. 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 Agreed. Now, another question I have, Arlen, is that is there an organization, and you don't have to name it, but is there an organization or a company you worked with where things were done really well? And can you walk us through or tell us a little bit about what were the elements that really made the initiative successful around digital transformation?
Yes, I mean, we've got many, many examples of very, very large companies, but
Mm,
the one that I'm thinking of, it was really early on, and it kind of patterned everything after that. Is that we had a document that they sat down and they said, this project will be a success if we can meet these four goals in our
right.
project. But
Right.
there's other 10 goals it would be nice to have. But if we can do these four, we will be successful. And that I think that set it up so that we weren't trying to boil the ocean. We were very focused on what
Mm,
this customer wanted to be able to do.
mm,
Now, we started looking at putting together a proof of concept. And the point that I made a while ago is that the technology is only 20%.
right.
I believe this particular project had a $4 or $5 million budget.
Mm,
And of that, more than $3 million were spent going out in the field to the facilities and looking at all their PLCs and all their sensors and all the equipment they had and all of the data they were leaving stranded in the field. That was that
wow.
was the that was half of the cost of the project was just figuring out what they had. But once they figured that out, man, everything after that
Mm,
went very, very smooth.
mm,
They did each piece of equipment that they had, they
mm,
continued to poll it, but then
mm,
they were publishing the information
mm,
MQTT into the
mm,
unified namespace.
mm,
They validated that, and then
mm,
they moved to the next piece of equipment, and then the next, and then the next.
mm,
And through that entire, it
mm,
was about a 2.5 year project.
mm,
They went from they were able to migrate from 100% legacy
Hmm.
to 100% event-driven
Wow.
MQTT, UNS, but all we were working back to that one document is, can
Mm,
we satisfy these 4 requirements? And we kept measuring that as we went through the project, and
mm.
we more than exceeded. We actually met all of the nice to haves as well.
Amazing. Amazing.
But it was top to bottom. The operations manager was literally involved in the process the entire time,
Right.
all
Right.
the way down, all the way
Yeah.
down.
Yeah. So if I think about what went right, first of all, you had the goals defined and documented, right? You had
Mhm,
people rallying behind them. And then it sounds like you guys worked together very well with the internal team. And then the third piece was the fact that the internal team, the operations manager and other folks were pretty well aligned.
mhm.
So I think
And
that's
and with all with a lot of your customers, I mean, this also did involve, system integrators. But they were very careful, and they didn't just bring in a system integrator and say, "Okay, here you got this silo, go fix it." It's
right.
okay. Here's our blueprint. There's the UNS on the wall. One time the SCADA manager said, "And creativity will be punishable by death." In the fact that we have a blueprint, let's
Right.
stick with the blueprint so that we know what's going on out in the field. Contract system integrators, they're great, but if they get too creative, once they're done, they leave, and now you don't know what you've
Right.
got.
Yeah.
And I think it's if you are using system integrators, and we work with hundreds of very, very qualified system integrators, but they do have to be read in, and they do have to know what the goal is.
Yeah. 100%. I love the point you made around making sure that you're not deploying and then walking away, right? You
Hmm.
are with them on that journey of making of maintenance in a way.
Hmm.
So I think
Yeah.
that's really important.
I don't, I've never seen a digital transformation project that hasn't kept evolving. You
Right.
don't just throw it in and go, we're done. Let's go
Exactly.
home.
Exactly.
It's a journey, and you're going to
Exactly.
stay with it. You're going to improve. So you did your first series of connect, collect, store, analyze. And then what do? You do it again.
Yeah.
Connect, collect, store, analyze. You do it
Yeah.
again. Connect,
Yeah.
collect, analyze. This needs to be improved. Let's go back and look at the data that we're connecting to. Maybe there
Yeah.
was an error there.
Yeah.
And it's just an iterative process. Nothing is magic going to fall out of the sky.
Right.
This is all just common sense stuff
Right.
of knowing your equipment. I was very fortunate, as I said,
Yeah.
in working for Coke Oil for 8 years. They let me do everything
Mm.
from, you know, run the ditch witch to put conduit in the ground, you know, trying to figure out how a PID loop works on a 5,000 horse electric motor pumping propane at 2,000 barrels per hour.
Mm.
And those are all things that our operational staff in our factories, they are our most valuable assets.
Yeah, 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 100%, 100%. I think that even when I even when I connected to the Lean Six Sigma principles, I have a lot of experience in it. Right? They talk about how it's define, measure, analyze, innovate, and control. Right? You want to make sure that you are able to you are updating, you are upgrading, but you're also controlling what you implemented or controlling the process. Well said. Well said.
Yeah.
Now, little bit. Let's go on the softer side or the more the fun side, I guess. Not that this wasn't fun, but anyway. So, my question is more around, you've done incredible work over the last 40 years, right? What has been your learning around timing, patience, some other factors that make for a successful person who's able to deploy or makes for a successful leader who is leading an organization going through digital transformation?
I was fortunate. I mean, I was very fortunate in that I always got to work with really good people. I was thinking about this the other day. Even in 1978, I was getting ready to quit. I
Mm,
was an electrical engineer at Oklahoma State, and I was on
mm,
the way out, and I saw this job posting
mm,
for an internship at Amoco Oil in Tulsa.
mm,
And I got to take that opportunity. And Joe Vitale ran the engineering department at Amoco, and they
mm.
gave just a huge amount that I learned there, and I really appreciated that.
Mm,
And I think through my career, it's been, I've always gotten up every day and look forward to what problem are we going to solve? How are we
mm,
going to solve that? And looking at, we can't just look at the status quo. How can we do these things
right,
differently? That's what I was saying about when Andy and I worked on MQTT. We weren't trying to create something that the Amazon cloud would use for their IIoT strategy. We were just trying to solve a problem for Phillips 66. And the as we progressed that, we did come up with a specification for using MQTT in industry, and it's called Sparkplug.
mm,
And that we donated that to the Eclipse Software Foundation.
mm,
So we are working with companies like Inductive Automation, Ep.22, Chevron, Flow. I think Aviva is going to be joining so that we can all come together on a common way for equipment like the Opto 22 or the ABB Flow computer behind me to publish information that then we can consume as solution providers.
right.
So my as we progress through this, I think we're going to get more and more equipment that will natively connect. And think about that. If you were doing a pharma or a bio project and all your sensors, they know what they can do, and they can
Right.
publish that into a UNS. Think about how efficient that would make that factory. It would be incredible.
Yeah, absolutely. Absolutely. I think, unfortunately, not many people are familiar with the OT space in such great detail. So I think the more we can educate people on this, right, the better it is. And I agree. I think the more we empower our leaders with this information, the better it is.
Yeah,
Right.
and not everybody maybe wants to get into the weeds on a particular protocol or the way a particular piece of equipment works. But we'll go back to that the really successful company that did digital transformation, they did have to get down in the weeds.
Mm,
Ultimately, they had Allen Bradley PLCs that were so old, they had to pay a huge amount of money to get the legacy programming software to get
right.
into the PLC to actually look at the values coming out because they didn't know if they were pressures or temperatures
Yeah.
or, you know,
Right.
furloughs fortnight. They needed that information. So I just can't fathom that until you get an organization to do the due diligence on the
Yeah.
operational equipment that they've got, that your journey into AI is not going to be successful.
100%, 100%. And I would say, right, at Skypreem as well, when we do the AI readiness, one of the key things we look at is the infrastructure. So you look at your process, you look at your data, you look at your organizational readiness, but then you look at your infrastructure. And that's where having understanding of the equipment becomes really critical, right?
Mhm.
What data are you getting from there? So, yeah, it's been great conversation, Arlen. Thank you very much. Any parting thoughts to our audience, to people listening?
No, no. I mean, I know we focused around MQTT. There's a lot. I mean, if you Google, if you just Google MQTT, you're going to find so much information. But I will mention the Eclipse Software Foundation. That's where the MQTT Sparkplug spec lives. And I love going. I do talk at colleges. And one of the interesting things I made the comment before about Raspberry Pi is the number of electrical engineers, chemical engineers, mechanical engineers in college they have Raspberry Pis or they've got these single board computers that they're playing with. And, I'll talk to them. How many of you are familiar with MQTT? And they'll raise their hand. They go, oh, yeah.
Mm,
I've got my Raspberry Pi. I can talk to my Amazon Alexa, and Amazon, if you set it up, Amazon can publish an MQTT message from the cloud to your Raspberry Pi to, turn your lights on or whatever you want to do. And I think all of these things are out there because one of the things and it's an issue that we talked about at Prove It, is getting engineers interested in operational and factory automation and things like that.
that's right.
And I think if we put that out there, that this is an interesting technology, it is leading edge, it is right out there with, all of the professions you could get into. And I think both you and I would be a contact point for any engineer that would want to be able to do that going forward, whether they're already employed and just want to learn more, or, want to learn more about the UNS or MQTT or Sparkplug, they should reach out to us after seeing this podcast.
100%, 100%. And I love what you said, right? Around the fact that we have to train our engineers. And I couldn't agree with you more. I think we have to train our next generation on some of these foundational elements, right? And because the world is changing, and I myself, I'm giving talks also and leading some boot camps. So yes, looking forward to working with you and working with whoever is listening. So thank you so much, Arlen. I also want to tell our audience that Arlen was the recipient of a very special Lifetime Achievement Award at Prove It Conference in front of, I want to say, over 1,000 people. So we are really fortunate to have him on the podcast. With that, stay tuned for the next episode. Thank you.